all of them got the first one. Yeah. But here I only want to mention, yeah, because some students wrote a lot of explanation. Yeah. Here, if you can notice, this 81 is 3 to the 4th. Yeah. Remember, in our review, we talk about evaluate monomial with the exponent power of 3, 3 to the kth power. In that case, we figure out the number of multiplications, 2k multiplications, right? Yeah, that's our review. Here, k equals 4, so 2k equals 8. Yeah. That's the reason. Yeah, here you can see it's possible. Yeah, we can do it. Yeah, but you have to have the background knowledge of this part, repeated cubing. Yeah. All right. When I do more grading, let me see if we have a few students who didn't have this background knowledge. Yeah. All right, let me move to the next one. Next one, oh, it jumped too fast. Yeah. You know, the software. When I touch something, it jumped to the end. Yeah. The second one, the answer looks fine, yeah, from those students. Yeah. Remember, we spend a lot of time, right? Here, I just add a few more zeros, a few more digits, but you got a point. You know, the exponential function eventually dominates any polynomial. Yeah. Or use that fact. Yeah. But if some of you do not believe that could happen, remember we use the Wolfram alpha. We can calculate. We can find that n. Yeah. So here, in the review, I use the Wolfram alpha, that online software computation application. Yeah, very powerful. Yeah, for relatively hard computation. Definitely here, you cannot use your hand calculator, right? Why so many students missed number 3? This is a big miss. Almost all those 4 students missed this one. Yeah, probably at least 3. Yeah, here I just based on my impression, may not be accurate. Yeah, based on my impression, at least 3 of the 4 missed the number 3. The answer is false. Yeah. All right. Oh, yeah, probably one student got it correct. Yeah. So the reason why here, without any other JSON version, remember here, the background is the bubble sort. When I explain the bubble sort, I use this background. We compare local inversion and a global inversion, right? Or the JSON we call a local inversion. Yeah, we know regarding the inversion concept, if there is no local inversion, then there is no global inversion. Yeah, because the global inversion, you based on the transitivity property. Remember, I talk about transitivity property of inequality. What's that? That is A less than B, B less than C implies that A less than C. That's the transitivity property. Okay, so think about that. This tells us any local in any global inversion will result in some local inversion. Yeah. Think about if you have no local inversion, by transitivity property, you won't have any global inversion. That's the logic. That's the logic. All right. So here, let me read the sentence again. It is possible for an array without any adjacent inversion. Without any, think about this. Without any adjacent inversion, when you see this phrase, it already tells you the array is sorted, right? No adjacent inversion, already sorted. If an array is sorted, how can you find a global inversion, right? Yeah, from that point of view, it's also correct, right? Yeah. But those students, the reason they missed with high percentage, yeah, based on their intuition, yeah, the local inversion, that property looks not strong enough to ensure that there is no global inversion. But if you are talking about some general phenomena in the real world, most of the time it is true, most of the time. Yeah. But for our specific situation here regarding inversion, that property is not true. Okay, that is not true. Yeah. All right, so that is the question number 3. Yeah. Next one. Yeah. Here you can see many questions I modified from our homework questions. Yeah. Small number from quiz questions, but most of the questions come from our homework 1 assignment. That question. Yeah. Number 4, given an n element array with n greater than 3 this time. Yeah, this one, the missing rate also so high, the missing rate. Answer is true. Almost all 4 students, as I remember, almost all 4 students missed this question. Let me explain. They gave me a lot of explanation. So let me point out why it is wrong. That kind of explanation, why it is wrong. Yeah. So given an n element with n greater than 3, yeah, it is possible to arrange these n elements such that all of them except 1 are not in place, right? So let me write it in a different way. Yeah, that is, this sentence tells us we like to do this. Okay, all right. 1 element is in place and the remaining n-1 elements are not in place. That is what we need, right? Yeah. I want to ask you if this could happen or not. The answer is this could happen, but all those students told me that could not happen. They explain in this way. Remember, we have another question, similar question, but the meaning is just the opposite. We did one similar question before. Okay, yeah. Let me give you that similar one before. That one is, all right. There are n-1 elements in place. But the last one is not in place? That's the question we did before. And we know this statement impossible. Right? That's what we did before. But at least the two of the students, they confused with our current question. These two completely different, right? Just the opposite. Okay. Yeah. In place, not in place, we switch these two parts. Okay. Yeah. Why? Number 4, it is possible. Remember, yeah. I drew the diagram before. Remember, we have a similar question in our homework assignment. All are not in place, right? We did this before, right? All the elements in an array are not in place. We did that before, okay? That is our homework question. Here, I just modify from that one. Yeah. I do not ask you all. I put one element in place. One in place. All right. Remaining all not in place. Remaining not in place. Yeah. You just think about the one in place. Can we ignore it? The one already in place, let's cover it. Let's cover it and ignore it. The remaining n-3 elements, let's treat it as a whole new array. How about that? In this whole new array, all elements are not in place. Is that possible? Based on our homework question, it's possible, right? Remember, I drew, I drew the way why it is possible. Remember that? We just do rotation. How about that? Okay. 1, 2, 3, 4. Suppose that's the, that's the normal position. Can we do rotation? 1 goes to 2, 2 goes to 3, 3 goes to 4, and goes back to, we just do one clockwise rotation. Then all the elements are not in place, right? Yeah, all the elements are not in place after that shift, circular shift operation. Yeah, here for the remaining n-1 elements, we do this kind of shift operation, circular shift operation. All the elements except 1 are not in place. How about that? Right? Yeah. So here you can understand that is the derived. We have the background. So we have our, old question as the background. But here you have to modify it. One element difference, you have to go through that change. So you can see, yeah, because when I design these questions, my main purpose, I want to, give you training on creativity. Yeah, you need some strong logic thinking for creativity. Yeah, so this kind of thing, I like you. So you can use your logic reasoning to fill the gap. There is a gap. Our old question, this new question, there is a gap. But your logic reasoning, you need to fill it. All right, so that's the question number 4. Yeah. Number 5, greatest common divisor, answer no. The reason is 0, 0, right? We did this question in our quiz number 3. Yeah, but here I just write, because I cannot use the same question, right? But when I make a new question based on an old question, I try to do the rewording. I try to change the way to write the same thing. Yeah, because in our quiz number 3, one of the question there, I ask you directly if GCD of 0, 0 is defined or not, right? Remember that question? But here, I try to hide a little bit. Yeah, because that's too straightforward. You know the answer immediately. So I try to hide, okay? Yeah, I make the assumption X and Y are non-negative integers. Non-negative integers including both 0, right? Both non-negative. So including 0, 0 case. Yeah. But you need to get to the point quickly. You know, the point is 0, 0, that special case is not allowed. So you need to, you know, find it, identify it quickly. Yeah. All right. So that's number 5. Yeah. Number 6, pretty good. Only one student missed this one. Answer is 7. Yeah. So you just write all the possible pairs. Yeah. You know, do that counting. Yeah. One student missed. One student gave me 8. Answer 8. Then I give partial credit. Yeah. Yeah. Because your answer is only one different from the real answer. So in that case, I feel, so you may get somewhere a little wrong. So I usually give you partial credit. Okay. Yeah. All right. Then next two, number 7, number 8. You can see I modify from our old 2 questions from homework assignment, right? But you know the result. Still, I estimate more than half of you couldn't find the correct answer. More than half of you. Yeah, that's my estimate. Yeah. Number 7, the answer is 7. Yeah. Here, we can make y equals x to the 6th. When you make that, then how many multiplications we need to find y, right? Yeah, you have 2 ways, but the answer is the same, okay? One way, x squared, 3 times, right? Another way, x cubed twice, right? Yeah. X squared, you need 1 multiplication, then 1 here, so total 3. Here, x cubed, you need 2 multiplications, but plus 1 more, you get 3. Okay? To find out y, you need 3 multiplications. Yeah, all right. Then remaining Horner's rule, right? Remaining a0 plus a1y plus a2y squared plus a3y cubed plus a4y, cube here. Yeah, why not try to erase? It's too slow. Yeah, cube, a4th to the 4th. All right, this Horner's rule, our answer is 4. The number of multiplication equals 4. 4 plus that 3, total 3 plus 4, that's 7. Okay, that's simple. Yeah, but I saw one student wrote long explanation, but in that explanation, that student didn't use the Horner's rule. Then your answer could not be very good. We know when all these a coefficients unknown, but here we do not know, right? We cannot assume any special structure. Then the best way to calculate Horner's rule. Horner's rule. Okay, all right. So then we have this answers 7, the best. Yeah, that's this question. Next question. This time, Pascal triangle, right? Pascal triangle, but inside it's 1 plus x cubed, then the whole thing to the 6th. All right. To calculate x cubed, we need the number of multiplication equals 2. All right. After that, raised to, yeah, you can think about 1 plus y raised to 6th power. How many we did in the previous question already, right? X to the 6th. Yeah. That in that one, number of m equals 3, right? Yeah. So then the total 2 plus 3 equals 5. That's why it's 5. We didn't use any new knowledge, right? Everything we practiced many times in our quizzes, in our homework assignment. Here you can see, yeah, I changed the form a little bit. Yeah, not too much, not too much. Remember in our homework question, I remember it's this one, 1 plus x squared, right? To the 4th. This is our homework 1 question. Okay, but here I changed to 1 plus x cubed, whole thing parenthesis to the 6th. Yeah, think about why some of you, yeah, I won't say some of you, yeah, but based on my estimate, more than 50%. That rate is too high. Yeah, should not be that high. Yeah. All right, so that's this question. Number 9, yeah, number 9. Yeah, based on my grading, it's pretty good. Yeah, remember that RSA encryption algorithm, right? RSA encryption algorithm, very famous. Yeah. Here, I'll give you the background. And oh, here, another related, yeah, let me talk about this story faster. Yeah. Another related thing in my another course, CS4010, here there are several students also in my that class. I ask my students do the prime factorization. Yeah, I assign a project 1 there. There is one feature they need to implement prime factorization, use Java big integer class. And then many students told me the decomposition is so slow. Yeah. And in my description, I asked them to do 100-digit integer decomposition. Yeah. Those students told me, you know, too long. So they have to kill the program. Too long. And one student even told me his computer looks like burning, you know, very hot. You know, when run, you know, this decomposition, it becomes very hot, you know. Yeah, that means prime factorization is so expensive, so slow. Okay, but that property is a good thing for this RSA encryption algorithm, because RSA, it uses this property not against us. It uses this property not against us, against hackers, right? Encryption, you want to make hackers' job harder, right? Yeah, you want to make, you know, what the hacker like to do impossible, right? Yeah, that's a good algorithm, right? Make hackers, you know, break down the encryption close to impossible, close to impossible. Why I say this close to impossible? because there is a potential possibility in the future, this algorithm will be, will be defeated quickly by quantum computer. Have you heard of quantum computer? Quantum, now it's not available. Now still in the research stage. Yeah. But if that quantum computers are available, this RSA algorithm won't be good. Won't be good. Okay. Yeah. That's the story behind this question, number 9. Yeah. All right. Next question. Actually, if you give this answer, then it's good enough. Yeah. I do not ask you to prove this is the best answer. Yeah. So here, I told you these 3 elements are in place. Then you assume they are, you can ignore these 3 elements. Then you just consider a question with 17 elements. Okay, n equals 17. Then we have a formula. Given n elements, we have this number, maximum number of inversions. Yeah. So if you use this property, this formula, then you get full credit. Yeah. When I see it, I give you full credit. Yeah. But actually, we may not completely solve this problem. Yeah, I agree with that, because if you completely solve this problem, you need to show this is really the largest possible number. So nobody can do better than this one. So there is another part, but that part is probably too hard for us. Yeah. Some of you, if you are interested, you can try. Yeah, but here I do not require that. Yeah, because this 136, it's doable, right? We know how to get it. Yeah, we know how to get it. Okay. Yeah, but the missing part, we are not sure if someone can do better than that. That's the missing part. Yeah, we know we can make 136 inversions in this array. Okay. Yeah, it's a pretty high number of inversions, but still there is one part missing. That part is too advanced for us. Yeah, so I do not require it. Yeah, yeah. So here I just let you know about this question. Yeah. All right. The next one, answer C. All those 4 students got it correct. Yeah, so I feel probably you can do this question well using the properties of golden ratio. Yeah, so I do not need to explain too much. Actually, if for the explanation, we know for phi squared, we can write 1 plus phi. For phi cubed, can you write some constant plus that form? For phi to the 4th, can you write, the linear form, then you're adding together, right? Yeah. So the basic idea is like that. Okay. Yeah, 1 by 1. At the end, you add up all of them. Yeah. All right. There is another way. I don't know if any students do in that way. You just use the, some powerful calculator. You plug in numbers and compare. Yeah. Based on my grading before, some students did in that way. Yeah. It's legal. I just want to say it's legal. Okay. Yeah. Yeah. All right. Number 12. given an unordered array with n greater than 2. This is important. Yeah. Those 4 students, at least 3 of them made it. Yeah. Probably 1 didn't do well in this one, but I look at their explanation. Some of them wrote explanation. The explanation, not quite good. Yeah. At least 2 students wrote a long explanation. Yeah, I read it, they didn't get a point. Yeah. Here, let me tell you, what is the point here? All right. It is known total K element. Oh, yeah, I got confused. Yeah, this one is good. The next one, yeah, the next one, what I'm talking about, the next one, yeah, we will see. This one, because odd number, right? Yeah, we did a question. I didn't put this odd number requirement. Then the answer K equals 2, right? K cannot be 1. We know K cannot be 1. Yeah. Yeah. So the minimum of K in our old question is 2, but here I just put odd number. Then automatically you can connect to 3. Yeah. Smallest odd number greater than 1. Yeah. 1 is impossible. So this answer is easy. Yeah. This one is easy. Yeah. All right. Yeah. Number 13. Yeah. This one. What I just talked about, I got confused myself. The problem I talk about is number 13. Answer B, no. Answer B, no. Because there is a possibility A equals B. Okay, A equals B. Yeah. Those 2 students, they try to show me if A equals B possible or not, but they wrote, a lot of formulas, go very far, asymptotic notations, yeah. But remember, we did one question in homework assignment. One, when n equals 3, how many comparisons we need to find the median? Look at that. Find the median. 3, right? The number of comparisons equals 3. Yeah. Sorting, how many comparisons we need for sorting? Also 3, right? By insertion sort. You just look at the insertion sort, we can do it by 3 comparisons. Are they the same? Here, that's the case A equals B. So we find a special example, A equals B when n is 3. Don't look at, other futures. So those students try to show me, when n is very large, it is possible. How can you show that, right? I cannot show it by myself. Actually, let me tell you the fact. Only when n equals 3, A equals B. If n greater than 3, always A greater than B. Nobody can show A could be the same as B when n is larger than 3. Nobody can show that. Okay? Yeah, actually, it's not the fact. It is not a fact. People can easily show A greater than B when n greater than 3. Yeah, that part can be shown. That fact can be shown. All right. Yeah. So here, is this our homework question? Yeah. So I hope you connect to our homework question. Then it's pretty easy to answer. All right. Yeah. Okay. Next question. Another homework question, but I modified. But surprisingly, most of you missed this one. Yeah. 2 students gave me option C. Yeah. Correct answer is B. Give me C, but it's close to B, so I'll give you a partial credit. I'll give you a partial credit. Yeah. It's close to C. The only difference is plus sign, minus sign. But that's still, not correct, right? Yeah. So can you see why B is correct? Yeah. Here, I do not ask you to calculate or prove. If you do that way, although it's illegal, but that's not good, right? That's not the best way, right? The best way, in the homework, we show this number positive integer, right? So you can find this result. The first two terms adding together positive. The last big expression, is this the Fibonacci number? F of n, is that? That's the formula, right? The last expression, Fibonacci number formula, exactly that formula. You know, Fibonacci number is positive integer, right? You know, when n is a positive integer. Only when n equals 0, it's 0. But when n is greater than 0, it's a positive integer. So you have positive integer plus positive, another positive integer, that must be positive integer, right? Think about that. Yeah, just use your knowledge about Fibonacci numbers and the golden ratios, our homework questions. You can quickly find that B option is correct. You do not need to do calculation. You do not need to, use some powerful calculator to check the values, although you can if you like, but too much work. Think about that, too much work. Okay, yeah. So that's this question. The missing rate is extremely high, yeah, for this one. Yeah. Number 15, answer 4, maximum, minimum simultaneously. Maximum, we need 2 comparisons. Minimum, we need 2 comparisons. Yeah. Maximum, because maximum, you just look at the, greater elements at the greater side, 2 x sub 4 and x sub 6. Okay, that's for the maximum. The minimum, lower side, right? Minimum, all right? Yeah. 2 plus 2, 4. Yeah. All right. Number 16, maximum, minimum. Yeah, but this time, max from 2 elements, 3 and 6. Minimum from also 2 elements, x1 and x4, right? Yeah. Most of you can see the solution easily. Yeah. But number 7, yes, this one you missed so much. Some students gave me 3, yeah, but the answer is 4. Okay, answer is 4. Yeah. All right, so here, let me explain a little bit. We know x1, x2 is greater. Okay, x3, x4, and x4 is greater. Then x5, x6 is greater. All right. Then we need to find the max first, right? Yeah. In order to find the second largest, we need to find the max first. Okay. Yeah. So do we need to compare x2 and x4, right? 2 of the winners, right? The first round winners. Yeah. So we can assume, let's say x4 a little better. All right. Yeah, because no big difference. Yeah. Then final round, these 2 here, you need to be careful. That's the reason some students pick 3 Some student give me 3, I just give them partial credit. If those students, yeah, because I see 2 students give me answer 3, 2 of the 4, 3 means it's not for the worst case. We want to find the solution for the worst case. Why not the worst case? Yeah, here, because here, both possible, right? X4, X6, both possible, but one gives worst case, another not a worst case. Yeah, all right. So here, if you put X4 here, that's the worst case. If you put X6 there, it's not the worst case. Yeah, because you can see X4 went through, you know, X4 beat more people, right? X4 beat more people. X6 beat fewer people than X4, right? Yeah, here. So you like to choose the one who beats more players. That will be, you know, more comparisons. That means more comparisons. All right, so now X4 is the max. Find the max, you need 2 comparisons, right? Yep. 2 more. So 1 here, 2 there. So 2 more. Yep. Because the lower level is given. So we do not need a comparison for the lower level, right? So 2 more. So then second largest. Next, second largest. Let us look at the candidates for the second largest. What are those elements that can be treated as candidates? That can be treated as candidates. Yeah. Cell phone, I have to, you know, shut down my cell phone. All right. So the candidates, you can see, yeah. The candidates, yeah, here, let me tell you how to find the candidates. Direct losers of the winner. The winner. Okay, X4, winner, right? Yeah, direct loser. Yeah. Let's look at which one was beaten by X4 directly. X3 was beaten by X4 directly, right? X2 was beaten by X4 directly, right? X6 was beaten by X4 directly, right? Yeah. All the other elements, they are not the direct losers of X4. That means they are not qualified to be the second largest because they were beaten by these people, these players, beaten by these people, right? So they're not qualified to be the second largest. Only these 3 are qualified for the second largest. But we find the largest of the 3, that's 2, right? 2 more comparisons. Largest of the 3. Largest of 3. How about that? So then 2 plus 2 equals 4. Okay, so that's question number 17, the worst case. Yeah. All right. Number 18, pretty good. Yeah, no problem. Yeah, So that's pretty easy. Yeah. So it's fine. Yeah. Number 19. Yeah. Surprisingly, it's very close to one of our homework one question, but that one, we have 5 elements. That one is median, right? That one we know X3 median. Here I only change X4 is the second largest. Can you use the same logic, same analysis to answer this question? Yeah. X4, second largest. So you know its position, right? You know its position. Can you take it away? Oh, what's wrong? Yeah. By accident, I touched something. Yeah. Yeah. All right. Can you take this X4 away from the consideration? Right? Yeah. Okay. Yeah. After you take it away, the remaining 4 elements, when you sort here, sort 4-element array, we know we did, right? We did in 5 comparisons. Okay, yeah. Connect this question with that homework question. The only difference is from median to second largest. But the thinking is the same, right? Why that median element is so important, right? Yeah. Any element, if its position is known, then we just treat the same way. No difference. We just take it away, do the sorting, then we put it back. How about that? We take those elements that are in place already, we take away. Elimination method, right? Why we take away? By the elimination method. All right. Yeah. So that's this question. Number 20 should be very simple. One student missed that. Yeah, but it is simple. Yeah. Number 21, large. Yeah. Many missed this one. Yeah. And here, X6 is the median. Can you use the elimination method here? X6 is the median, so it cannot be in top 3, right? Median cannot be in top 3, right? Yeah. Cannot be in top 3. Can you eliminate it? If it's not, there is no chance for X6 to be in top 3. Can you eliminate it from the consideration? Then after elimination, you only have 10 elements, right? 10 elements to find one in top 3. Is that 10 minus 3 equals 7? Right? The method to use, if you draw a diagram, 10 elements, 10, suppose, here. All right. Can you just choose 8 of 10 first and find max of 8 of 10? Max. Find max element from those 8 elements, the number of comparison equals 7, right? N minus 1, 8 minus 1, 8 minus 1, 7. 7, this max beats 7 of, all right, so here, that max beats 7 out of 10. Must be in top 3. How about that? That max already beats 7 out of 10. That's enough, right? Top 3, any top 3 element, you only need to beat 7 out of 10. Then you're comfortably in top 3. Think about this logic. Think about this logic. Okay. All right. Yeah. I only have 5 minutes. Let me try to cover as much as I can. Number 22, easy. You get it easily. Yeah. Number 23, a little hard, but top 2, neither in top 2 nor in the minimum. All right. Some students saw that relationship, yeah, but many didn't. Yeah. Here, let me draw the picture here. All right. I draw a vertical bar represent the given array. Okay. Top 2 and the minimum. Okay. All right. Now we need to find element somewhere below top 2 and above minimum. How many comparisons we need? So we want to find this one. All right. Look at the number of elements. How about we just select 4 elements? Select any 4 elements from the array. Okay, yeah. Then find the second smallest. In the array. Find the second smallest in the array. How about that? Yeah. Given 4 elements, find the second smallest. We did before, right? 4 comparisons. Yeah. Remember in our previous question, we already did it. Okay. Yeah. Question number 17. Yeah. Yeah. Question number 17. Yeah. Actually, it's not. You know. Question number 17 is similar. Yeah. But question number 17 modified. Yeah. Similar. But we did it in homework. Remember, in homework assignment, we have one question that is this one, right? Yeah. Yeah. So from homework assignment 1, remember we have a similar question. Okay. Yeah. Answer is 4. All right. Then number 24. Yeah. This is my last one to explain. Yeah. Because 25, you just look at my solution. All right. Yeah. Number 24, this number n equals 15. That's one of our homework question. Remember in that one, our answer n minus 1 plus n minus 2, right? That is one swap operation. That's the maximum number of inversions that can change. But how about, let's do the second one. Can we do the next 2? 4, right? That's the second swap. So we just use the same way, but this time, because after one swap, you make 2 elements in place. Yeah. So now you consider the old n becomes n minus 2, right? Yeah, because 2 already in place. You eliminate those two elements. Yeah. Eliminate 2 elements. Okay. After that, then you apply, the previous formula again. You get n minus 3 and n minus 4. So then you get that 50. How about that? Yeah. Yeah, but some students may argue, this is just the one way to get the answer, but how do you prove that's the maximum, right? Yeah, I agree there is such argument. But here still, I do not need to prove this 50 number of inversion is the maximum, but we know it's doable, right? We can make this happen with 50 inversions. Then if you make 50 inversions, I'll give you full credit. That's what I can tell you. You got full credit with 50 number of inversions reduction. Yeah, that's it. That's good enough for me. Okay. Yeah. All right. Let me stop here. Yeah, because we got hit by that interruption of the Zoom